Alright, so we are talking about finding the surface area and volume of cones and pyramids. Okay, so really it is just the same thing that you learned before. It's just a cutout of those same shapes. The formulas are on your formula sheet, but they're a little bit tricky. There's parts that you need to find sometimes before you can actually use the formula. Before we jump into that, we're just going to talk about what is volume and surface area. Volume is the space that's inside a sheet. Volume is just talking about the inside of the sheet. It's actually literally how many little cubes you can fit inside of a sheet. Some keywords that you'll see for that are fill, or really sometimes you'll just see the word inside, how much you can fit inside. The units are also a giveaway for what we're looking for. If we're talking about meters, it would be cubic meters. And just a shorthand for that would be the M of meters with a 3 on it to imply that it's cubic. The units, some keywords, and that description could all tell you exactly what you're looking for in a work problem. Similar for surface area, we're talking about the space on the outside. I don't want to use the word space again because that's actually talking about like actual space of volume. I don't really like using the word area, but there's no better word really. It's the area on the outside. So you might see the word outside, or you might see the word cover. That's a really commonly used one. Cover. Also, sometimes there's really specific examples, like if you're painting the outside, or if you're making an aluminum can, you're making the outside of it. Actually, I'm going to even write the word paint because of how frequently that's used. Very few times when we talk about like the paint that's inside of a can, you're talking about painting the surface of a whatever. Either way, it's the surface, it's the outside. And let's stick with meters. If we're talking about meters, but we're talking about area now, instead of cubic, it will be square meters. With the m squared, or meters squared. So sometimes you're given everything that you need, and you really just plug in the numbers. Sometimes you actually have to find missing parts before you can plug them in. These are all, the formulas are all given on your formula sheet, so you don't need to memorize any of these. Volume of a cone is 1/3 pi r squared times h. Actually, I'm going to write the surface area one too, just to compare them. Surface area is pi r squared plus pi r L. So there's a bunch of weird looking things in there. Obviously, pi is really just a number. The radius is common between both of those. The radius is the same. It's halfway across the circle and halfway across the circle. That's the radius for r. The height is different from these two. This height goes straight up and down. This is on your formula sheet. You don't even really need to memorize this. It's directly on that formula sheet. It shows you that the height, well, let's change colors, that height is going straight up and down from the peak down to the middle of the circle. The only difference is that this one has L in it, and L is not the straight up and down height, but the slant height. That's what I'm going to call this. That slope side, that's called L, or the slant height. Let's do that since I already have the green one. L is our slant height. The H That is the normal height that just really goes straight up and down inside the plane. So our unit last time, well actually by now it's a couple units ago, Pythagorean theorem is going to be really useful here because we have a right triangle here. So sometimes we're going to be told the height, this, and you have to figure out the slant height. You have to figure out what is that. Or the opposite, you'll be given the slant height, you'll be given that, and you might need to find the straight up and down height. But you can see that right triangle right there is made from the height, the radius, and that slant height. The height, the radius, and the slant height form that right triangle. Which side is the slant height there? It's always, yep. That's a really easy way to check to make sure that you're doing it right. Your C, the slant height, is always longer than the straight up and down height. That has to be your longest side. Always think about what you need before you just jump into solving a problem. Look at the formula, even write it down, the first couple times especially, write it down. We're trying to find the volume of the cone. The volume of the cone is 1/3 pi r squared times h. So what do I really need to use that formula? What two things do I need? Yep, right.
The height and the radius.
Height and the radius. And that's exactly what I'm getting. I don't need to find anything there. I really just need to plug those numbers in. The radius and the height can just get plugged in there. 1/3 times pi times r squared, which is 11, times 22. You really need to follow order of operations here, so I'm thinking I'm going to do that exponent first. That gives me 1/3 times pi, 11 squared, it's not 11 times 2. Still seeing that mistake a couple times. It's 11 squared, which is 121, times 22. Now you can multiply all of those together. Don't be scared, it's a big number, it's going to be a big number. What did you get from that? Amy, what did you get from that? Why not? Somebody else? What did you get? Yep. Point 22. Actually, I'm going to leave it right there. I'm going to round that to the hundreds place. In general, if you're not told instructions, just round to the hundreds place. Yep. You get a different decimal. Okay, so if you use the pi key versus 3.14. If you use 3.14, I think that's what you're going to get. If you use the pi key, I think you get something slightly bigger. And actually, I want to round that to a 3 really. So if that's a 66 after, I'm going to round that to 2, 3. So that's if you use the pi key. That's if you use 3.14. If you use the pi key, I'm guessing that's what you got. You use 3.14? Something went wrong. Try multiplying those out again. Oh wait, maybe it's rounding that. Don't use 0.33. Use 1 divided by 3. Leave that decimal in the calculator. Then do times 3.14 times 121 times 22. Don't round that. You didn't? Try one more time. Oh, it's really because you're rounding there. Don't even round that. Just do that times the 121. Okay? Yep.
Can we get the radius of the surface area? The second one? Is it the 11 or?
It's still 11. Yep. Right. On that second one, we're trying to find surface area. Now we actually need to find something before we just jump into using that formula. The surface area is pi r squared plus pi r L. And I really want you to do this in two separate steps. I want you to find that and then add them. Otherwise, order of operations might get messed up. Really just find what is that, and then add those two numbers together. Before we can even use that formula, though, we need to find L. This 22, that's H. The 11 is the radius still. So we have the radius, but we don't have that L. We have 22 as the height of this triangle. 11 as the base. We don't have that C yet. We don't have the slant. How do we find it? Good. We're going to use Pythagorean theorem, so we're going to use a squared plus b squared. That equals c squared. And we're missing the c. The slant height is always the c. So you do 11 squared plus 22 squared equals c squared. Remember, in Pythagorean theorem, if you're given the two short sides, you add them. If you're given the long side, then you'll subtract. So I'm going to do 11 squared, that's 121. 22 squared is 484. That equals c squared. I'm going to add those together and then do the square root of that number. I'm going to get 605 from adding those together. And then do the square root of that, which tells me that C, or my slant height, actually C and L are really the same thing. What did I get from that? Let's keep the 0.46 for now.
24.4.
20. Yeah, it's going to be 22 then.
24.4.
Yeah, it's 22 point. Actually, that we can round to 6. Let's call that 24.6. That's the square root of that 605. That's what we should have. So all of this was just so that we can figure out the number that we can plug in there. We're actually not even really done with it. That's just to figure out what to plug in there. But now I'm really just substituting numbers in. I have the radius, which is 11. I use that twice. And I use this 24.6 as that L. Still follow order of operations, so I'm going to do this X mark first. It's pi times 121 plus pi times 11 times 24.6. I'm still going to use the 3.14 there. So I get 379.94 plus 849.68, and then I add those together, that gives me my final answer of 1,249.62. What are my units there? Yeah, they're squared here. What about on the first one? Yep, that has a 3. This is talking about volume. The second one's talking about surface area. On a test, I won't mark it off if you forget that, but really, you should be able to do that. Whatever the units are, if you're thinking about volume, it's a 3. If you're thinking about surface area, it's 2. All right, I'm going to have you try these two on your own, but I just want to guide you a little bit on this first one. We're trying to find the volume, which means we need the straight up and down height. We actually don't have that yet. You have to find that using that right triangle. You have 13.4 as the slant height, 6 is the base of that triangle. You have to find this. I'm going to call that B. You're going to find that using Pythagorean. All right, those are the two answers that you should have gotten. Yours might be slightly different because of either using the hotkey or 3.14, or really just because of rounding. But that's generally what you should have gotten.
I got.
4.1.
What's up?
That's what I'm saying. If it's slightly off from that, that's okay. But your height should have been 11.98, or if you rounded to 12, I think that's what I did. I rounded to 12, so I got it slightly higher.
Which second answer is 11?
Did you use the height of 11.98, or did you use the slant?
Wait, I got 451.4.
That's still okay. Okay, you wanted to use the slant height. You're using that as L. So pi times r squared, which is 6 squared, times pi r. You're using 13.6.
Wait, why is that L the only thing that differs?
Because if I write it as a line, then there's so I don't have to write it. Although actually on the formula sheet they write it that way too.
Or you can just do.
That's true, then it's capital, and we're going to distinguish between capital B and lowercase.